Hello everyone, welcome to our another video. In this video we are going to learn some more very important concepts of thermodynamics, that is maximum work. Let's talk about concept of maximum work. The amount of work performed by a system is governed by the opposing force, Pxt. What is a Pxt? Pxt is external atmospheric pressure. If you learn previous expression of pressure volume work, that is a PV work, in that we got one expression, that is W is equal to, I am writing here, W is equal to minus Pxt, I can't write here properly, but you should understand this, in bracket V2 minus V1, V2 minus V1. So what is a V? Volume of the gas in initial and final state of the system, and W here is a work is done by the system on the surrounding. This expression shows the external pressure determine the work during expansion or compression of the gas. Larger the opposing force, that is a Pxt, more work is done by the system to overcome it. If the opposing force is 0, no work is involved with an increase of the opposing force from 0. More work will be needed by the system. When the opposing force reaches its maximum, the system performs maximum work. When the opposing force Pxt becomes greater than the driving force, here the new concept is come, that is driving force. This shows the force is exerted by the solution. What is the difference between Pxt and P? Pxt is the pressure, external atmospheric pressure, and P the pressure exerted by the solution, so inside pressure. The process get reverse. Okay, when this is the case, the opposing force become greater than the driving force, the process get reverse. So P is a greater than Pxt, so P minus Pxt is nothing but the difference in the pressure, that is a delta P. If you taking this in a one side, so Pxt is equal to P minus delta P. Therefore W work is done by the system on the surrounding is equal to minus, put this Pxt into this expression, so W we got W is equal to minus as it is sign, then Px is nothing but the P minus delta P. Okay, put it to here, and delta V, V2 minus V1. Expression for the maximum work. Consider n mole of an ideal gas enclosed in a cylinder fitted with a frictionless movable piston. It expands isothermally and reversibly from the initial volume V1 to final volume V2 at temperature T. The expansion takes place in a number of steps, as you can see in the figure. So this is your cylinder, this is piston, V1 initial volume, V2 final volume. Difference between this volume is a dV. During each step, the external pressure Pxt is made infinitesimally smaller than the pressure P of the gas with a gradual removal of the masses from the piston. If you decrease the mass of this piston, then this gas is expand, and at every time this P would decrease. This is your P. P means your driving force, and this is your Pxt. So if you decrease the mass, P is going to decrease. The expansion continues until the pressure of the gas falls to Pxt. Beyond this, no further expansion occurs and the system attains mechanical equilibrium with its surrounding. The volume of a gas is increased by an quantity dV in each single step. As you can see, this is your dV. Okay, so when the volume of a gas increases by an infinitesimal amount dV in a single step, the small quantity of work is done. So now dW is equal to minus Pxt dV. As the expansion is reversible, P is greater by a very small quantity Pxt. This P minus Pxt is nothing but dP, because this is the difference. Take Pxt in one side, so P minus dP. This is your expression first, this is your expression second. Combining this expression, both expressions, dW is equal to minus, what is dW? Here it is a Pext. This is the Pext. Pext is nothing but what? P minus dP. So put here P minus dP and dV as it is. So solve this. P dV plus dP dV. Neglecting the product dP dV is very small. We get dW is equal to minus dV. You have a clear idea about dW is equal to PdV. This is equation number 3. Let the state of the system change from A to B, that is a P1 V1 to P2 V2 isothermally and reversibly. What is isothermal and reversible expansion? A process where there is a rise in a volume at constant temperature. The total work or a maximum work in the process is obtained by integrating above equation. Write down the same equation and integrate them. So from initial to final state, from V1 to V2, because the volume changed from V1 to V2. Hence, because of this integration, only W is remaining. So is equal to V minus V1 to V2 PdV, as it is equation number 4. Using ideal gas equation, PV is equal to nRT. So what is a P? P is equal to nRT upon V. V is going down. So this equation, P is equal to nRT upon V, put to this equation number 4. So what is now new equation? W max is equal to minus V1 to V2. This P is nothing but nRT upon V. Write down here, and dV. So V is now shifted to this one. So nRT is given out in the next step. Why? Because T is a constant here. So minus nRT, integrating V1 to V2. Now 1 upon V dV is same to the dV upon V. Why we have to write this? Because of the one integration formula, as integrating 1 upon x dx. Integrating 1 upon x dx is equal to log to the base e x. So just take this log to the base e v. X means v, and v1 to v2. Why we are just adding this v1 to v2? Because this is the difference, v1 to v2 is equal to nr minus nRT log to the base e v1 to v2 upon v1, because this is the minus, you know this formula, v2 upon v1. Now the new formula is come, that is a log ex. Log ex is nothing but 2.303 log to the base x. Log ex is nothing but 2.303 log to the x. So W max is equal to nRT. W max is equal to, this is nRT. This equation we have to rewrite nRT, okay, and log ex means this one. Log ex is nothing but we have to write 2.303 log to the base 10 v2 upon v1, as it is we have to write here, okay. Here is our final equation, that is W max is equal to minus 2.303 nRT log to the base 10 v2 upon v1 at constant temperature. P1 v1 is equal to P2 v2. V2 upon v1, interchange this P1 upon P2. So v2 v1 upon v1 is equal to P1 upon P2. So our equation may like this: W max is equal to minus 2.303 nRT log to the base 10 P1 upon P2. From V1 to V2 you can also write P1 upon P2 from this, okay, where N, P, V and T represent the number of moles, pressure, volume and temperature, and this is our final equation. For the process, delta U means change in internal energy 0, change in enthalpy, that is delta H is equal to 0. The heat is absorbed in the reversible manner. This is why, because the heat is absorbed in a reversible manner. So Q reversible is completely converted into work. So Q reversible is nothing but minus W max, hence the work is obtained is maximum. Thank you so much.